What's up, guys? We're back. So as you can see, we got that massive 19-inch fan in there with this custom shroud we made for it in the last video. Fits nice and tight. Everything looks good. So let's go ahead and jump on the laptop and we'll get right to it. All right, guys. So we went ahead and pulled the file off the truck and got it open here just to speed things up. So first thing we're going to do is we're going to go to our inputs and outputs. You can see we have our 12-volt AC signal there. So that's good. Go to outputs, and here's the one we're going to be working with. It's currently a ground for the electric fans, so we're going to put that as singular, and then we're going to change the signal to the PWM negative. We made a change, so we're going to have to reconfigure it. I didn't have to pin map this because, again, we already had this pre-wired on the IO stub over there, so we're going to use that same cable. We're just going to change the type of signal that it sends out. So okay, now we're going to go to configure. This output will activate when the AC signal is enabled, correct? That way we get the fan going when the AC is on, even if the motor is not demanding it. And the other sensor input trigger, which is going to be coolant temp, we're going to have this come on at 180 degrees and deactivate, we'll say 170. The thermostat will never let it get that low. So again, since it's duty cycle controlled, we'll just run it. If it's the truck's at 180, we'll just have it run, very low. So that looks good there. And then we're going to go to the PWM setup. This timer and linked output stuff, you don't really have to worry about it. So we're going to go to the PWM setup. The type is going to be fixed. The frequency, according to my research and this for this fan, it's 128 hertz. That's what works best. So we're going to do that. The table units, we're going to do it by duty cycle. And our x-axis, we're going to do coolant temp. And our y-axis, we're going to go ahead and do RPMs. You could do TPS as well if you wanted to come off after, if you wanted to turn off after a certain RPM. Let's say you're racing or something, so above 75% TPS, you can have it turn off. You can do that as well. In this case, I'm just going to do RPM to keep it simple. And here we go. So this is the table that we got. We're going to go ahead and rescale this. We'll start it at 100 degrees. We'll go all the way to 250. Okay, so it filled it out, but I want to do it by 10, so let's go ahead and fill this out manually. Okay, so there we go. Okay, so the operating range of this fan is between 10% and 90%. I think it's like 91, 92, but we'll call it 90 since after 90, it doesn't draw any more amps from what I tested on the bench here. Okay, so my goal is to keep this truck at 200 degrees. So I'm just going to throw a guess out there, estimated guess. I think at 70% duty cycle, the fan should keep this truck, the engine at 200 degrees. Again, I'm just guessing. This is what we're gonna go test drive and mess with all this. But this is these three right here. This is mainly the area that we're gonna be focusing on. This over here is gonna be mainly for the AC. All this stuff over here. So okay, since they'll turn on at 180, we'll have them run right here. We'll do this row. We'll have them at 40%. I'm sorry, it's a single fan. And from over here, let's say the coolant's at 100 degrees. Outside, it probably means it's around 105-ish degrees. So that's pretty warm. I want AC here in that temperature range. So right here, we'll just have it run at 35%. Because again, the fan could turn on. The engine will demand it to turn on right here at 180. But if I have the AC signal, at 100 degrees, the AC signal will also, that input will also turn on. So we have to scale the whole table accordingly. Otherwise, if we were to leave this blank right here, it wouldn't, all this area blank, it wouldn't turn on even if we send it that signal, because it wouldn't have a PWM. It wouldn't have a duty cycle basically to send the fan. So that's why we have to fill it out. Even if it's just 35%, I think 35% will produce enough airflow to get this fan going. Okay, so then right here, we'll just do, in between, we'll do a 55% at 190. And again, 200, that's our goal, to keep this truck at 200 degrees. So I think 70%, it should keep it there. If it starts rising a little more right here, let's say it goes to 210, you know, after a pass or something, we'll have it run at 75% to bring it back down to 70%. Again, that doesn't mean it's always going to run at 75%. That little bubble will be moving around here, you know, but 70% is where we want to keep it. If it goes to 220, yeah, we definitely don't want it there. So we'll do 80% here. And if it's at 230, let's say, you know, a really hard uphill pass or something, then we're going to run this thing at 90%. So that's kind of what this looks like. Again, this is just for the AC, 35%. That should produce enough airflow. This thing moves a ton of air. That should produce enough, that should get enough air going through the condenser. Once we get to 180, we'll have it run at 40%. 190, we'll do 55%. And again, at 200 degrees, I think 70% duty cycle, this fan should keep it there where we want it. So, okay, this is how this looks like here. We're going to go take this thing out on a test drive and mess around with this table, and then we'll come back and see how it turned out. So hopefully it's not too loud in here. It's about 3 p.m. right now, about 105, 110 degrees, but we've got the AC going and everything on this thing, nice and cool in here. I'm currently sitting at about 195 degrees, so it's not too warm yet. The fan's working, I can hear it. So it's mainly that stop and go, you know, like I said, I was killing it. And on the highway speed, not so much, but on that stop and go, you know, we can start getting up there and we want to see it come down, you know, that's the most important part. So that's what we're mainly looking to achieve, and to start messing with this table so far, it's pretty good. It's keeping it at 190, so we might have to, you know, move the whole table a little bit further to a little hotter side of the engine, but let's see how it goes, and we'll grab some burgers or something. Driving around for a while now. I had to scale it. I had to move the scale a little higher up because it was taking forever to get to where I wanted it, 200 degrees. Man, I need to stop. I'm on tires. But anyway, yeah, we just had to move it a little further, but about 70% seems to keep it where we wanted it, which was at 200 degrees. And the fan's only drawing about 35 amps, so that's not bad at all. We were drawing, you know, like 40 amps with the other setup, but they were running at 100% all the time. So we're gonna get a few harder, duty cycle narrower, if anything, to get the truck up to temperature faster, and not have it draw as much amperage and not have it work as hard if it didn't really need to. So we're gonna go ahead and go back to the shop, and we'll get on the laptop then, and I'll show you guys how it ended up. What's up, guys? So we're back from our test drive. Just thought to show you guys here the updated table. We moved around a little bit of stuff, mainly the temperature range down here. We closed it up a little bit from the 90 to 180 mark, since right here is just for AC. 40% of this fan, it's only drawing about 10 amps, and that seems to move enough air for the condenser. Right now, the truck, again, this table's not dialed in, but the truck, according to our test drive, it stays around 190 to 195. So I'd say, yeah, that we were right in the ballpark with that 70% of the duty cycle, and it's only drawing about 30 amps. So I'm happy right there. Again, it's not dialed in. I still want to get some, different driving conditions, but this is just kind of, what my table looks like. It might be different for you, depending how big of a motor you got, or where you're at. Right here we have a brutal summer, so that's why we got to run this thing a little hard. But right now, maybe that it's cooling off, might move it over here, more towards the 210 range, since the air will be cooler outside. But this is, again, what worked for me according to this test drive. We're still going to dial it in a little bit. We'll play it as we go, and that's the beauty of this Holley stuff, man. Just take my laptop anywhere and literally make adjustments on the fly. All right, guys, well, that's going to go ahead and do it for this video. We went ahead and took this thing off for a rip. Runs great, super fun to drive, and definitely a lot more peace of mind with that fan on there. That thing moves some serious air, man, and the efficiency of it is unmatched. So I hope you guys learned a thing or two with me. Again, if you haven't watched the first video, be sure to check that out. We did more of the install. This is more of the technical video of the part 2, setting it up on the laptop and stuff like that. So if you guys are still undecided on switching over to the brushless stuff or not, I definitely would. Work great for me, and like I said, the efficiency of these things is basically unmatched, man. It's great. We're definitely not going to have any overheating issues. I don't see it, any trouble at all. And this is in the summer, this is as hot as it gets. So I mean, in the winter, this thing probably won't even be turning on. So again, thanks again for watching. Hope you guys learned a thing or two. Leave a comment if you guys have any questions or anything like that. More than happy to help out. And let me know what you guys think, of these videos. I got a bunch of work planned out for this thing now that the days are getting nicer. So we'll go ahead and be recording a bunch of that stuff. And yeah, go ahead and let me know, what you guys think, what you guys want to see more of. So thanks again for watching.